All right, so hi everyone. So we'll be looking at abiotic factors and zonation. And what zonation really is, it's really a species distribution. So why is it that there's a group
Okay.
of species over here as opposed to over there? And let us start out with an activity. So let us think about the following. Think about a map showing settlement patterns. So this is where we're looking at where various communities are located. So you'll find that when you're looking at the map of Jamaica, most of the settlements would be found along the coastline. So I don't know if you're familiar with the geographic layout of Jamaica. So we have a mountainous interior, like a backbone throughout the island. So the flat land is towards the coast. And so most settlements, you can find most houses, most communities, or major cities, all of them are along the coastline. And why do you think that's the reason? You have to open your mic and speak. I don't think I can see the chat. No answers. Think about it.
What you say,
Why is
Miss?
it why is it that you would build a house on the land that's closest to the coastline rather than a house up in the mountains?
There won't be much rain.
Rain? Well, yes,
There
climate is
won't
a
be as much
factor.
rain.
Climate is a factor, yes. Accessibility, so you're looking at access to food, access to road, proximity to the city, and other basic amenities, whether recreational activities. The fact that it's easier to build a house on flat land rather than in a mountainous, rigid area. All right, let us think about the other example. A river showing fish distribution. So we realize that when we look at a river system, we're seeing that the fish is in a particular section rather than another. So what could be the reason? So we don't know anything about the river. We're just looking at the river and we see that the fish is more towards the right over where the rocks are and all of that. Like, we looking at it, we're not seeing any difference, but what do you think could be a reason why the fish are congregated or in schools over that side and there is no fish in this area? Think about it. It might be that there is more food over the right side of the river. It might be that they feel more protected in that area. It might be that the temperature is right over there. The area where the fish are absent might be affected by human activity. And so there are different reasons for the distribution of people, fish, animals, plants, everything you can think of. And the things that affect their distribution are the abiotic factors. And we know what abiotic mean, right? We have an idea? Just checking the chat. Nobody's talking in the chat?
Yes, Miss.
Yes, you have an idea? All right, awesome. All right, so species distribution. Basically, each species on our planet occupies a unique geographic range where the members of its various populations live, feed, and reproduce. So anywhere at all you find a living organism, they must be able to live, feed, and reproduce in that area, or else you really won't find them there. Because living organisms require, there are basic needs that each of us have. There are basic needs that plants have. They require sunlight, they require water and minerals to make their own food. There are basic needs of human beings, and there are basic needs of even fish. And some species have extensive geographic ranges. So that means that they can stretch over several continents. So you can find them on Africa, you'll find them in Antarctica, you'll find them just about anywhere. And usually these organisms are microorganisms. So species with such distributions are known as cosmopolitan species, right? So that's a vocabulary word right there, cosmopolitan. And other species can have more restricted geographic ranges, isolated to a small area on a single continent. And this type of distribution is termed endemic. So Miss Shola Collins, your ecology tutor, she would have given you a lovely presentation on species that are endemic to Jamaica, right? Do you guys remember any? You can drop 2 examples in the chat. And so the reason why these species are endemic is because they love the climate, they love the food, the variety of food that they're able to get, that this place, this island is able to provide for them. They could not survive in another island. This is where this is the restricted geographic range that they can be found in. So let us look at distribution. So geographic ranges of organisms continually shift, expand, and contract with the passage of time. So these changes are the result of 2 contrasting processes. So basically, the geographic ranges of organisms can actually change. Yes. So yesterday, I think it's yesterday that you guys learned about extinction, right? So
Yes.
an organism, yes, so an organism would have been established in an area, and that area would have been providing it with its basic needs, the food that it needs to eat, the air that it needs to breathe, and the comfortable grass or bed that it needs to sleep, right? And over time, the establishment of a species takes place when individuals colonize new areas and are able to maintain reproductively viable populations. So that means they're having just enough boys and just enough girls so that that population can reproduce and sustain itself and continue to reproduce and add to the numbers. So when mommy and daddy dies and then the babies come and they live and there are more adults adding to the population and more babies. So new suitable habitats for establishment may open up because of abiotic and biotic environmental changes. So what that means, just for want of an example, is, so you know, abiotic factors have to do with the non-living components of our environment, and the biotic factors have to do with the living components of our environment. So the living components might be, there's a particular fish species that was just introduced in the lower channel of a river. So the larger fish would normally be in the upper channel because that's where they have food and all the things that they need to survive. But when this new fish species was introduced in the lower channel, you started to see a geographic change or change in the distribution of the big fish in the river because they're going to go where the food is, right? So say for example, now it wasn't the fish that caused the big fish to move from the upper channel. Say it was some kind of pollution or pollutant enter the river stream from the upper channel and cause the fish to not be able to live there anymore. So they have to move. So it can be voluntary or it can be involuntary, right? That's just what I was trying to explain. So species are always attempting to expand their spatial distribution. As it becomes better, their chance for long-term survival. So the more places that a species is able to occupy and survive and live, it is better for that species because they're able to survive longer. And of course, extinction is a process that eliminates members of a species from all or part of its geographic range. So extinction occurs when large numbers of individuals from a species are killed by biotic interactions. And biotic interactions, examples of that would be feeding. So you're looking at relationships like prey and predator. So that species might be a delicious meal for another animal, and the animal just start to attack them. It's like I don't know if you guys know about the Portland deer. So there's a deer that exists in Jamaica, in Portland, lovely cool hills of Portland, but they're heavily hunted by the maroons. You know, the maroons are still living in Jamaica. So because of that, they are close to being extinct, or they're currently being protected because they're being hunted. And when a particular animal is being hunted at an alarming rate, you have to put measures in place to protect them before they become extinct. So limited extinctions occurring within small subregions of species range are quite common. So it happens all the time. There are different biotic and abiotic factors that might contribute to that. So let us look at species tolerance, because this is the thing, this is the number one factor that will say where a species can live and where a species cannot live. So most species appear to be limited in at least part of their geographic range by abiotic factors. So these abiotic factors are temperature, moisture availability. So you know, temperature is whether it's hot or cold. Moisture availability is there water in the environment? Is there water in the soil? And soil nutrients. So is there nitrogen, phosphate, all the lovely nutrients that plants need to grow and blossom. So no species is adapted to survive under all conditions found on the earth, right? So do you have human beings living on Antarctica for years to come? Yes, you have research scientists who might visit Antarctica from time to time, but can humans live there without a coat that's probably double padded and all of these things, right? So there is no one species that is able to adapt to all conditions found on Earth. Can we live in a volcano? There are some microorganisms that actually can survive the heat of lava. So all species have specific limits of tolerance to physical factors that directly affect their survival or reproductive success. So there are instances where species might be found in a particular area that might be of an extreme, but it might affect their reproductive ability. So because the place is too hot, the fish is unable to reproduce, for example. So the portion of the abiotic factors range of variation richer species can survive and function in is commonly defined as the tolerance range. So if a species can survive between 25 degrees Celsius and 30 degrees Celsius, anything above and below that range can kill the species or can potentially harm the species, causing them to act in a deformed manner. So the level within the tolerance range at which a species or population can function most efficiently is termed as the optimum. So it's an optimum condition when it is that the species is living within the ranges that it's able to survive. Everything is airy when things are optimum. You have the optimum amount of food, the optimum amount of temperature, the optimum amount of comfort. Everything is just, it's all right. It's all set in that environment. So let us look at how abiotic factors affect distribution. So the community or the ecosystem that we'll be looking at to assess the effects of abiotic factors is the estuary. Are you guys familiar with what an estuary is?
No, miss.
No? All right, great. Awesome. We like to learn new things.
Yes, miss.
Yes, all right. So an estuary is a partially enclosed body of water where two different bodies of water meet and mix, such as fresh water from rivers or streams and salt water from the ocean. So basically, let me show you what an estuary looks like. I'm sure we have seen it. So you guys know where the mouth of a river meets the ocean. So you know the river is running into the ocean, and there's this
Yes, miss.
body of water that's right at the mouth of the river, but the ocean has a channel where it can enter, and the river water is there. So it's mixed. So it's a mixture of fresh and salt water. So in estuaries, all plants and animal species live in a transition zone. And this transition, it's a transition zone, or it's termed as a transition zone because it's where fresh and salt water meet. So factors that cause change in estuarine environment fall into two categories. So you have abiotic and biotic factors. So abiotic factors are those that occur in physical environments such as amount of sunlight, climate, and the geology of the area. While the biotic factors are those that deal with the organism and other organisms they share their environments with. So are these organisms competing with each other? Such as when the lionfish came into the Jamaican waters and started to eat our parrotfish and other organisms such as our lobsters, our shrimps. No, the lionfish is competing with the fishermen who are trying to catch the parrotfish themselves. So let us dive right into the abiotic factors and look at how these factors affect the living organisms in the estuary. So pH, so we learned what pH is, right? We learned it yesterday from Miss Henry. So pH is a measure of how acidic or basic a solution is. So the pH scale ranges from 0 to 14, and solutions with a pH of less than 7 are acidic, and those with a pH greater than 7 are basic or alkaline. So knowledge of pH is important because most aquatic organisms are adapted to live in solutions with a pH between 5 and 9. So if the pH is between 5 and 9, what is that saying? Is it acidic or is it alkaline? Which end is it more leaning towards? Yes, it's more leaning towards an alkaline or a basic end. So the pH in an estuary tends to remain relatively constant because the chemical components in seawater resist large changes to pH. So biological activity, however, may significantly alter pH in freshwater portions of the estuary. So biological activities that can affect pH would include excretion. So if there is a large amount of feces in the water, it can become very acidic. So don't forget that, guys, that that organisms in an estuary or in most environments, they prefer basic conditions. Nobody can survive in acid, although there are certain bacteria, yes, and microorganisms that can survive in acidic environments. And this explains the pH scale, but it was explained yesterday, so I won't go into it. However, the information is already uploaded to Google Classroom, so you can read at your leisure. So let us look at temperature. So just knowing the temperature of the water in an estuary can give us a pretty good idea of how healthy it is. One important thing we can tell from water temperature is how much oxygen can be dissolved in the water. So dissolved oxygen is critical for the survival of animals and plants that live in the water. as the temperature increases, the amount of oxygen that can dissolve in the water decreases. And that is an important chemical relationship that affects animals that live in water bodies. So what this is saying is that temperature, even though temperature, the sunlight might not have a direct effect on fish, whales, sharks, but it can affect them, because remember, these organisms still need oxygen to survive. The fact that if the temperature is too high, it can reduce the amount of oxygen that the water body is able to dissolve, right? So the temperature has to be right. It has to be an optimum temperature, usually room temperature between 25 degrees Celsius and 30 degrees Celsius, for the oxygen to dissolve in the water so that these organisms are able to get the oxygen that is required for their survival. All right, so don't forget that relationship. Temperature is directly linked when you're looking at estuaries or oceans. Temperature, when you're talking about temperature, you're looking at dissolved oxygen, because dissolved oxygen is directly affected by the temperature of that water body. So if the temperature is too high, the amount of oxygen that can dissolve is going to be low. All right, so all plants and animals have a range of temperature in which they strive and reproduce. For instance, someone will only breed at temperatures below 18 degrees Fahrenheit. So if the water in the estuary is outside the normal seasonal temperature range, in which most estuarine organisms can comfortably live, it is probably an indication that something is adversely affecting the health of the estuary. So again, the temperature of the water body, so while it affects the dissolved oxygen, it can affect the organisms in a way where it can affect their breeding season, because there are some fish that rely on warm temperatures to start spawning. And when we say spawning, we mean the fish is reproducing. So dissolved oxygen. So to survive, fish, crab, oysters, and other aquatic organisms. In fact, as a marine biologist, I can tell you that fish, I mean, not fish so much, but crabs and oysters and shrimp, lobsters, those are they're most sensitive to levels of dissolved oxygen. The very minute that the dissolved oxygen level falls, you see a lot of them starting to die or get diseases and get sick. And so, you know, it's very important, the role that abiotic factors play in these ecosystems. It's just so important, right? And it's important that we try to maintain these abiotic factors and have them ensure that that the range in which they actualize are optimum. So to survive, fish, crabs, oysters, and the other aquatic animals must have sufficient levels
Lanika? She's up here? Yes, yeah. Guys, just hold on for a moment. Miss, I have to go now. Okay, all right, Jermaine, you can just. I don't know what happened to Lanika. I don't know if she's.
Hi.
Bye bye, guys.
Yeah.
Lanika, you finished the presentation?
No, my internet went.
Oh, okay.
I'm almost through though. Like,
All right.
yeah. All right. So I think this was a slide. So I was saying that oxygen enters water through two natural processes, and one is the diffusion from the atmosphere, and two is the photosynthesis by aquatic plants. So there is algae in the water, and these algae and phytoplanktons, they photosynthesize, and a byproduct of photosynthesis is oxygen. So the atmosphere around the water body provides oxygen along with the aquatic organisms that is in the that lives within the water body. They provide oxygen as well. So the mixing of surface waters by wind and waves increase the rate of which oxygen from the air can be dissolved or absorbed into the water. So dissolved oxygen levels, or otherwise known as DO levels, are influenced by temperature and salinity. So the solubility of oxygen, or its ability to dissolve in water, decreases as the water's temperature and salinity increase. So if the water is too salt, or if the salinity is high, then that means it will be much difficult for oxygen to dissolve. So therefore, dissolved oxygen levels in an estuary can vary seasonally, with the lowest levels occurring during the late summer months when temperatures are highest, right? Bacteria, fungi, and other decomposers can reduce dissolved oxygen levels in estuaries because they consume oxygen while breaking down organic matter. So let me explain this part. So bacteria and fungi, these are decomposers. So when an organism dies, the bacteria and the fungi attack the dead flesh and start to break it down so it can return to the sand or the soil as nutrients, right? So while the bacteria and the fungi is breaking down the organisms, they actually use oxygen. And since they will be using oxygen, they will be decreasing the availability of oxygen for the other living components in that ecosystem or in the estuary itself. So oxygen depletion may occur in estuaries when many plants die and decompose, or when wastewater with large amounts of organic materials enter the estuary. Because when wastewater with these large amounts of organic materials enter the estuary, bacteria and fungi get so happy and they start to rejoice and say, oh my God, look how much food is there. I can go and I can eat all of this and use up all of the oxygen that is in the estuary. And so there is no fish or no shrimp or no crab or no oyster that will be able to get any oxygen because I'll be using it all as I dive into this organic matter that is now entering the estuary, right? So while decomposers are awesome and they do good, they can significantly reduce the levels of dissolved oxygen, affecting the availability of oxygen for other living organisms around. So this is why it's important that the temperature is right so that everybody can be happy. We know once the temperature is decent and the salinity level is decent, then enough oxygen will be there for everybody to enjoy. All right. So why is it important to monitor abiotic factors in estuarine environments? So I'm sure I touched on quite a lot of points, and we see why it is important. It might be complex. I know it might be a lot to take in at once, but they're all interrelated. They're all interconnected, and this is the beauty of ecosystems. Abiotic and biotic factors, they both have relationships. They both play significant they both have a significance or play a significant role in the environment or the ecosystem of which they are part of. So it is important to monitor parameters such as pH, temperature, salinity, and DO. What is DO again? Anybody remember what DO stands for? Drop it in the chat. And of course, it's important to monitor these parameters because each of these factors must remain within a certain range to ensure the survival of species living in the estuary. So each of these parameters can exceed their normal range, and they will from time to time. So there are different events that might happen, whether these events can be normal or human-caused events. So normal would be like a storm or a flood or a drought. I know with drought comes extensive sunlight and the temperature might rise. And of course, human-caused events such as runoffs from farms, factories, power plants, and sewage treatment facilities. So all of these activities can affect these parameters. So they might cause the pH to rise or fall. They might cause the temperature to rise or fall. They might cause an increase in salinity or a decrease in the salinity level. And they can affect the dissolved oxygen levels. So how is, let me see what this is saying. How is surviving in an estuary different than surviving in a forest, a desert, or the open ocean? So remember we said that a estuary is like a transition zone. So there is fresh water and salt water coming together. So of course this environment would be very unique, and you know their ability to kind of, well, let me read what is there. So surviving in an estuary is difficult. Yes, it would be difficult. And my internet connection is unstable again. I hope it doesn't fall, but I'll be finished within less than 5 minutes. So in an estuary, environmental factors can change rapidly. Yes, conditions in estuaries vary more than in many other types of habitats, and dramatic changes in pH, salinity, and temperature occur frequently and regularly in estuaries. In deserts or the open ocean, conditions are more stable and changes usually take place more slowly. So basically, an estuary is a very volatile environment. It's susceptible to change, and this is because it doesn't necessarily have a control. It's such a small ecosystem, one, and you know, depending on the wave activity of that day or the wind that is blowing, that will determine how much salt water is mixing with the fresh water, as the waves will storm in with a whole slunge of water, and with a whole a barrel or whichever of salt water mixing with that fresh water, and then after a while, you know, it's either it's going to be extremely salty that day or extremely fresh. You know, if rain falls and the river comes down, if the river comes down, you know, once the river is flowing, all of that salt water is just completely diluted, right? So that is what this is really saying. It's a very difficult environment because it cannot control the different things that will happen to it. And I think this is the last slide. I really do think it is. Okay, awesome. So are there any questions?
Not really, miss.